Module 2.2, Linear Equations and Complex Numbers. This is chapter 1.1 through 1.3 in your book. Module 2.2 Opener. The idea behind equations is to observe and analyze when things are balanced, when they're equal. And the easiest type of equation to work with is a linear equation. That's the type of equation we're going to work with here. But later, a lot of these properties are going to apply to trigonometric equations also. We're also going to study complex numbers, which are not part of the real numbers that we've studied so far, but they are, again, very useful with trig problems. Some things to focus on in this section. Always make sure that you're keeping an equation equal. Remember, it's an equation, it has to be equal. So you can't do one thing to one side of the equation if you don't do it to the other side of the equation. If you add something to one side, add it to the other side. If you multiply to one side of the equation, multiply to the other side of the equation. When solving for a variable in an equation, always check your work. Now, this is the easiest step. It should be one thing you always do. You want to know if you have the right answer or not, just check it. Just plug the number back in. When working application problems, it's a good idea to sketch the problem. This is going to be probably the most important thing you do in this section. You're going to learn a lot of formulas. You have to memorize a lot. But the easiest way that you can be sure that you're working the problem correctly is if you sketch the problem. Remember, scratch work is going to be important. Objective 1, linear functions. A linear equation is of the form ax plus b is equal to 0. In other words, the highest term is the x term. So for example, if we wanted to solve 3 times x minus 2 is equal to 5 plus x, we could start by just multiplying things out. 3 times x and 3 times negative 2 is 3x minus 6 is equal to 5 plus x. Right? And again, make sure you always do something to both sides of the equation. So here, if we wanted to get rid of the negative 6, we would add 6 to both sides. If we wanted to get rid of this x, we would subtract x from both sides. And that would give us 3x minus x is 2x. Negative 6 plus 6 is 0. It's equal to, always make sure you put the equal sign down. 5 plus 6 is 11. X minus x is 0. I'm going to divide both sides by 2. Divide the entire sides by 2. So we get x is equal to 11 over 2. Okay. It's a linear equation because at the most we have just some number in front of the x and then some other constants to deal with. Like, working with fractions can sometimes be seem a little difficult, but it's not so bad as long as you do the same thing both sides. Here we're trying to solve for 1/4 times 2t plus 1 is equal to t plus 1 over 3. Right? The easiest thing to do is get rid of the 4 and the 3 in the bottom. So that way you're working with a linear equation, just one line. So we're going to multiply by 4 and by 3. In other words, we're going to multiply by 12 to both sides. 12 divided by 4 is 3, so we're left with 3 times 2t plus 1. Again, because 12 divided by 4 is equal to 3. Is equal to, and 12 divided by 3 is 4. So this might as well say 4 times t plus 1. Right, then we can multiply everything through. 3 times 2 plus 1 is 6t plus 3, 4t plus 4. Combine like terms, subtract 4t from both sides, gives us 2t plus 3 is equal to 4. Then subtract 3 from both sides, gives us 2t is equal to 1. Finally, divide both sides by 2. T is equal to 1/2. And you're done. An identity is an equation that is always true. So for example, identity would be something like 2 is equal to 2, always true. Or x plus 2 is equal to x plus 2, always true. A conditional equation is an equation that is sometimes true. So a conditional equation would be something more like x plus 2 is equal to 5. That's not always true. It's only true when x is equal to 3. A contradiction is an equation that cannot be true. So if we have something like x plus 2 is equal to x, this can't be true, because if x is equal to 1, for example, then this would read 1 plus 2 is equal to 1, or 3 is equal to 1, which is false. There's no number that we can choose for x that would make this true. So it's a contradiction. Objective 2, solving applied problems involving linear equations. This is very important that you try to do this on your scratch paper. When you try to solve an applied problem or a word problem, you're going to want to read and rewrite the problem. So if you're given information, just rewrite the information anyways. Right? Make sure you draw the problem. You want to have an idea of what you're working with. And even if you think you have an idea of it, it's always better to draw it yourself. Ask yourself, what is known and what are you trying to find out? What do you know and what do you need? Usually this is the variable that you're going to say is called x. Choose and assign your variables. This goes along with choosing what you're going to call x or what you're going to call a, b, or c. You might have more than one variable that you need to find, but you need to say what it is that you want to label them as, and then write it down. Write an equation, possibly using geometric formulas. Here you're gonna have to memorize a lot of equations: area of a circle, area of a rectangle, area of a triangle, etc. And with practice, you'll know which one to use. The easiest part about this is solving the equation. Once you have everything set up, then you just have to do the math and solve an equation. And then finally, you'll check your work, of course, just to make sure that your answer makes sense. So let's start with a interesting question here. Suppose we have a mixture problem here, and it says how many gallons of 50% antifreeze solution must be mixed with 60 gallons of 25% antifreeze to get a mixture that is 40% antifreeze. So again, we're given a lot of information, but we should always write it down again. So we're going to write this down. It says how many gallons, and we're going to sketch it out just to visualize it. How many gallons, how many should give us an idea that we're saying X. That's what we're trying to find, X gallons of 50% antifreeze. So let's sketch this out. Let's say that's the antifreeze right there. And it's 50%, 0.5 in decimal. 0.50 must be mixed with 60 gallons, so plus, let's say that's 60 gallons right there of 25% antifreeze, 0.25 antifreeze. To get, in other words, equal to a mixture that is 40% antifreeze. So this mixture will eventually be 0.40. We don't know how many gallons we need, but we know that X plus 60 is what we have in the end. So drawing that out gives us enough information to be able to write down an equation. Here we have 50% of an X amount, so 0.5 times X plus 0.25 of 60, and that should equal 0.40% of X plus 60. And look, we have a linear equation that we can solve for. So we're going to multiply this out. 0.5x plus 0.25 times 60 should equal 0.4x times 0.4 times 60 plus 0.4 times 60. So it's 0.4x plus 0.460. We can go ahead and combine now. We can go ahead and, you don't have to multiply these numbers out. Let's go ahead and subtract 0.4x from both sides. That would give us 0.1x. And let's go ahead and subtract 0.25 times 60 from both sides. 0.25 times 60. So here they cancel. I'm left with equals. Here this cancels. 60 of 0.4 minus 0.25. 0.4 minus 0.25 is 0.15 times 60. Look, we've almost got x solved for. We just need to divide by 0.1. Let's go ahead and try that on the calculator here. It's easy, it's just multiplying by 10, but let's do it. 0.15 times 60 divided by 0.1, or times 10, will give us 90. So we have that x should equal 90 gallons. Here's a quick review of some useful formulas. The distance formula for something traveling in a straight line says that the distance it travels, d, is equal to the rate of travel times the time it traveled. So for example, if you're trying to find the distance, if you're going 20 miles per hour for 2 hours, that would be 40 miles. The area of a rectangle, I'm going to draw it over here, is equal to A, is A equal to B times H, where B is the base of the rectangle and H is the height of the rectangle. So the area is the inside, remember. The perimeter of a rectangle, in other words the length all the way around, is one base plus a height plus another base plus another height, or two base plus twice the height. And that's the length all the way around the rectangle. The area of a triangle, given that we know the height of the triangle H and the base of the triangle B, is base times the height divided by 2. The area of a circle, given that we know the radius of the circle, is pi, the number pi, which is approximately equal to 3.14. Pi times the radius squared. And again, that gives us the area inside the circle. The circumference of a circle, in other words, the perimeter of the circle, or all the way around the circle, is given by 2 times pi times the radius r. And we'll also use simple interest formula in your, you'll use it in your homework. And that is that the interest is equal to the principal amount, the starting amount, P, times the rate of interest, R, times the time in years. So the interest is equal to P times R times T. Objective 3, defining complex numbers. Really quickly, we need to analyze the solutions to x squared is equal to 1 and x squared is equal to -1. They look similar, but they're not. X squared is equal to 1 has one obvious solution. 1 squared is equal to 1 works, because 1 times 1 is 1. Also, -1 works. -1 in parentheses squared is equal to 1. So Those two work. What about x squared is equal to negative 1? What type of number works there? There are no real numbers that work here, right? Because any real number squared is always positive, so there's no way that this is come out to be negative. For that, we need a new definition, a new type of number, which we call I. I is defined to be equal to the square root of negative 1. So that way, if we were to type in I in there, in other words, the square root of negative 1 squared, square root of negative 1 times the square root of negative 1, right? That would give us negative 1. So we found something that works. Not only that, but negative I would work there too. Because negative I squared would be negative 1, negative I times negative I. The negatives cancel, and we're just left with I times I, or the square root of negative 1 times the square root of negative 1, which is equal to negative 1 again. So I is equal to the square root of negative 1 is a solution. A complex number is a number of the form a plus bi. In other words, a is any number, any real number, and b is any real number, but we're multiplying b times I. So for example, 2 plus 3i is the same thing as 2 plus 3 square roots of negative 1. That's a type of complex number. Not only that, but algebraically speaking, if we take the square root of any negative number, we can always factor out I. For example, negative 5, negative square roots of 5. Because negative 5 can be written as negative 1 times 5, and we know by the properties of exponents that this is negative square root of negative 1 times the square root of 5, and we know the square root of negative 1 is I, we can just write this as I times the square root of 5. Objective 4. Operations on complex numbers. So the usual rules and properties apply to complex numbers. The only thing you really have to be careful is that you can't combine the real part with the imaginary part. So if we can't combine any a's with b's, for example. If a's have to stay with a's and b's have to stay with a's. So for example here, we want to write negative 8 plus the square root of negative 128 over 4, the whole thing over 4, in standard form. We want to write it as just some number plus b times some imaginary number. So we're going to separate it. This is negative 8 over 4 plus the square root of negative 128 over 4. Negative 8 over 4 is negative 2. We're almost there. Plus, and we need to simplify this. Square root of negative 128. This is negative 1 times 128. Half of 128 is 64. So 64 times 2. Why do I want to use that? Because the square root of 64 is 8. So here I can write this as the square root of negative 1 is I, the square root of 64 is 8, and the square root of 2 is just the square root of 2 over 4. So finally this reduces to negative 2, 8 divided by 4 is 2, so plus 2i square roots of 2. And we have something of the form a plus bi. Here our b is 2 square roots of 2. Okay. So let's start off with some easier examples here. Find the sum of 3 minus 2i plus 2 plus 4i. Again, the only thing you have to be careful with is that you can only combine the real parts with the real parts and the imaginary parts with the imaginary parts. This might as well read 3, this 3 plus that 2. And this negative 2i plus this positive 4i. 3 plus 2 is 5. Negative 2 plus 4 is positive 2. And we're done. Find the product. Here we're going to multiply just like before. We're going to distribute everything out. And we're going to combine like terms. So distribute, and that's the key right there, distribute and only combine like terms. So 2 times 1 is 2, 2 times 3i is 6i, negative 3, again remember the negative sign matters, negative 3 times 1 is negative 3i, negative 3i times positive 3i, you have to be a little careful here, negative 3 times 3 is negative 9, I times I is I squared, then we're going to simplify, 6i minus 3i is 3i minus 9, but remember, what is I squared? I squared was the square root of negative 1 times the square root of negative 1, which is negative 1. So this I squared is negative 1, so this might as well read negative 9 times negative 1, or positive 9. So really we should have combined the 2 and the 9 to get 11 plus 3i. Be careful here. Remember what I squared means. Let's try one more. Remember, notice here that we have a similar looking thing here. 2 plus 4i and 2 minus 4i. So you might guess that some of the stuff cancels out in the middle. But let's work it out the long way. 2 times 2 is 4. 2 times negative 4i is negative 8i. 4i times 2 is positive 8i, so they do cancel. 4i times negative 4i is negative 4i squared. 4, in other words, this should read plus 4, because I squared is negative 1, so plus 4. So the answer in the end is 8. So notice we had two complex numbers, and the number at the end came out to be completely real. To divide complex numbers, we multiply the numerator and the denominator by the conjugate of the denominator, just like we did with square roots before. Here we don't want an imaginary number in the bottom, so we're going to multiply by 2 plus 3i. And we're going to multiply by 2 plus 3i in the top also, just like before. So let's go ahead and do this. 3 times 2 is 6. 3 times 3 is 9i. 2 times 2i times 2 is 4i. 2i times 3i is 6i squared, or minus 6. Here in the bottom we get 2 times 2 is 4. 2 times 3i is 6i. Negative 3 times 2 is negative 6i. Negative 3 times 3i is negative 9i squared, so plus 9 actually. And then we combine like terms. 6 minus 6 is 0. 9i plus 4i is 13i. 4 and 9 is 13. 6i minus 6i is 0. So we're left with 13i over 13, or just I, just the imaginary number I, which again is the square root of negative 1. Now finally notice that because of our definition of I being negative, the square root of negative 1, I squared is equal to the square root of negative 1 times the square root of negative 1, or negative 1. I cubed is just multiplying by another I, so it gives us negative I to the fourth is equal to I squared times I squared. In other words, negative 1 times negative 1, which is positive 1. And then after that it repeats. I to the fifth is just I to the fourth, which we know is positive 1, times I. So it's just I times 1. I to the sixth is the same thing as I squared. I to the seventh is the same thing as I cubed. I to the eighth is the same thing as I to the fourth. So you don't have to remember these after I to the fourth, because they'll be the same. The cycle repeats after 4 times. 1, 2, 3. 1, 2, 3, 4. So if we were trying to find I to the 42nd, notice that 4 goes into 42 at least 10 times with a remainder of 2. So this is very similar to, because 42 divided by 4 is equal to 10 with a remainder of 2. This is the same thing as I squared, which is equal to -1. I to the 64th. What about that? And we're going to ask ourselves, how many times does 4 go into 64? Well, 64 divided by 4 goes into it evenly, actually. Goes into it, let's see, it goes into 40 10 times, and it goes into 24 8 times, so it goes into it 18 times. Point being that there is no remainder. This is the same thing as saying I to the 4th, which is just equal to 1. If there was a remainder of 1, it would mean it's the same thing as I. If it's a remainder of 2, it's the same thing as I squared. Remainder of 3, the same thing as I cubed. And if there's no remainder, it means it's the same thing as I to the 4th. Now you should try these problems on your own. Okay, again we're going to multiply 9 plus I to both the bottom and the top. Notice here, you should get a little bit better at doing this. 9 times 9 is 81, 9 times I is 9i, I times 9 is another 9i, I times I is I squared, or -1. 9 times 9 is 81. 9 times I is 9i. Negative I times 9 is negative 9i. Should cancel, remember, because we have 9 minus I and 9 plus I. Negative I times I is negative I squared, or negative 1, which is plus 1. I'm going to simplify to get this 80 plus 18i over 82. And then you could simplify this yourself if you wanted to write in complex form. You could write 80 over 82 80 over 82 plus 18i over 82, and so on. What about I to the 43rd power? This should be the same as I to the 3rd power. Why? And what is that equal to? That's the same thing as I squared times another I. I squared is -1, so this is just negative I. You should be ready to start on Module 2.2 homework. And again, if you have any questions, please let somebody in the lab know.